All right, you guys ready now? Class?
Yes.
Okay. All right, good job. Gotta show some enthusiasm for this. Now, so when we talked about this yesterday, we have perpendicular lines. Symbol for perpendicular is the upside down T. If the slope of M1 is A over B, perpendicular to that would be opposite, so this is positive, the other one's negative, so it's a negative B over A. So opposite and reciprocal, so they gotta have both of those. They are gonna be perpendicular to each other. We're gonna start dealing with some of these other things in which that we will refer to as something as a tangent. Tangent touches the edge of a circle at a single point, creating a 90-degree angle. And that 90-degree angle, I know, has to be perpendicular to the radius of that circle. So if I have any straight line right here, it's touching at a singular point right there. That means that if it only touches at any single point, that means that it will be perpendicular to the radius. Always. And this is something that your geometry teacher did not teach you, because I know we stopped teaching it a while ago, and then every year since, no one knows this stuff. So it makes life a lot more harder for me. Anyway, but yeah, that's one of those things. Find the equation of the horizontal and vertical lines through this point. Now, on your notes, let's see if you guys paid attention yesterday. The horizontal and vertical lines. So label it, okay, accordingly. You can look back in your slides to find a definition for horizontal and vertical lines, and use that point to tell me each. Don't feel bad if you have to look back. There's a reason why I give you fill in the blank notes. Do it. Label it horizontal, then get the equation. Label it vertical, and then give me the equation. All right. I'm going to start with my vertical line. Vertical. Okay. Vertical line. My equation for vertical line would be. What do you start? What does vertical line always start with? Vertical is up and down, right? Nope. No. Vertical, straight up and down, is an x equals. X equals. Go take a look at the notes on that one. So the vertical line is x equals. Okay, and my a in this case is going to be -3. X comma y, right? Okay, so the vertical line would be x equals. What about my horizontal line? Horizontal goes this way. That one would be a y equals. And in this case, my y equals what? There you go. Yes? No? Maybe? Possibly. Okay, I'm not trying to trip anyone up. I'm trying to go back over and refresh everything because some people, drank so much bong water they forgot what a bong is. It's all right. Equation for a line through this right here, parallel to the line with this equation. Okay. So the line through that point, and it's going to be parallel. So for part A, your equation, which is y equals 2x minus 8, and through the point of 3, 5. Now, I want you guys to try this, and I'm going to give you a hint starting out. What do we know about parallel lines? What did we learn yesterday about parallel lines? They do not touch each other, but what else did we talk about yesterday? It's in the notes. What? Same slope. Same slope. That's the important part here, right? Yeah. Okay, same slope. So now if we know that they're the same slope, I'm creating another line that's going to be parallel to that line. So let's try it again. So parallel lines have the same slope. What's the slope of this one? 2. Okay. So now, do I know the slope of my next line? Yeah, of the parallel line that I'm going to make, right? Okay, and what else was also given to me? So I have the slope, and what else is given to me? What else do you have? What is this thing right here? The point. Let's try this again. You have the point and the... What do you think I should use to try to make an equation of this? I'm going to use the point slope. Is there an equation that's actually called point slope? Yes, there is. That's the reason why I'm trying to go back over all these things. There is an equation for that. So you could just use, what form for this? I could use? Point slope. There we go, point slope. Do it. You don't even need to simplify it. I could just use that equation. So therefore, it would be, let's change up colors, why not? It would be y minus 5 equals 2 quantity x minus 3. That's point slope. There it is. Now, does it say I need to make it into a standard form? No. Does it say I need to turn it into slope-intercept? No. Okay, so we have a form just for that. In calculus, you don't have to simplify for everything. Some things you do because you need to use that answer for your next part of the problem, but a lot of things don't simplify. You have a form for it. Just leave it. Yep. So, the next one. The line with the x-intercept 6 and perpendicular to this line here. Okay. And so x-intercept, right? X-intercept of 6, and it says it is perpendicular to 2x plus y equals 7. Now, what does the word intercept mean? Cross, right? It crosses. This one crosses the what? The what?
Oh,
It crosses the, okay, so it's the x-intercept. So the word intercept means to cross the x, right? So the x is that line going left and right, isn't it? Yeah, so. I think I have a graph here somewhere. There you go. X, Y. X, Y. That's X. That's horizontal.
I think we're just confused with the other, we were showing us that's a vertical line.
Oh, yeah, I know. That's why I'm trying to use as much of the language, the verbiage that you're gonna get here, because when you open up the book and you start doing some of these problems, so you don't say, oh, what the hell is that again? Okay, so yeah. So don't ever be afraid to ask questions, because I will always be here to help you. I will, okay? Because I don't know what you don't know. So I know that you guys actually had some bad teachers, okay? At what point, I don't know. But there's probably some gaps in your learning. Every person has had a different type of education. You all might not have had the same, that covers everything. And what if you were absent the one day that they talked about that? Life goes on. Anyway, so alphabetical order is X comma Y, right? Okay. My x-axis is here, my y-axis is here. Okay, so x-intercept. So it crosses the x. Very good. It crosses the x. That's important when we're talking about this. The x-intercept means it's crossing the x. So I'm going to put, 6 here. So at this location right here, what's the y value?
0.
Very good. That's important to know and understand, because that's what we need to get from that. Because it's not just giving me one value, it's actually giving me both values. In a ordered pair, there's two values. There's the x and the y. So we have the x value, but since we know it is the intercept, we also have the
Y value.
there we go. So I know that this has to be 6, 0. Everything has keys and just the wording to give you clues to go through this. Everything has that. You just have to try and problem solve to work through what clues do you have. So there we go. So now we have a point. So from this one over here, I got to try and figure out the. Yep, very good. Got to figure out the slope. So this is in my standard form. So to get this out of standard form, I am going to turn it into y equals mx plus b. So let's get y by itself. What am I going to do to that positive 2 to get y by itself?
Subtract.
Very good. Let's subtract 2 from both sides. So subtract 2x from both sides. Y equals negative 2x plus 7. So in that form right now, I know that my m is negative 2, right? Okay. My m, my slope, is negative 2. Now, slope is always referred to as rise over run, right? Rise over run. So any whole number I have, I could rewrite it as a fraction. I could just divide that over 1. Any number divided by 1 still gets the same number. So I'm just going to say, hey, this is negative 2 over 1, right? And it's going to make this next part easier. So the perpendicular, so the slope of the perpendicular to that is going to be opposite reciprocal. So if I'm starting with the negative, I know I have to end up with a
Positive.
positive, and that 2 over 1 is now going to turn into a positive 1 over 2. Right? 1/2 or 1 over 2. Now, what information do I have now? I now have the point and the,
Slope.
so I could use the,
Point slope.
very good, point slope. Do it. Go. All right, we good there? Yes?
Yeah.
Oh, happy day. And part C, let's see. The perpendicular bisector of the segment with the endpoints. Ooh, a lot of good words. I love all this. So 2, 3, 6, 17. So I want perpendicular bisector. So perpendicular bisector. Now, I gotta find a couple different things. So right now I have 2 points. The tools that I've given you so far is I know how to find the point slope. Can we find the slope of this?
Yes.
Because if I know I'm gonna do perpendicular, I know I'm gonna end up having to deal with the slope, right? I'm going to take my slope of my original and do the opposite reciprocal. Yeah?
Yes.
Okay. So I know I got to find the slope in between those points. So let's go ahead and start that. Okay? I'm going to go ahead and start that. So let's see. So my delta y. So delta y. Delta y is going to be 14 over delta x 4, which will
reduce to 7. No, it doesn't want to work anymore.
7 over 2. Yeah. Okay, so now let's go ahead and start with my perpendicular. Since I know my slope, so the perpendicular to that slope would be, very good. Now, what does the word bisect mean? Okay, 2, right? If you dissect something, what do you do?
Cut in half.
Okay.
Well,
Yeah, the whole thing is cut it in half. But yes, dissect means to cut it, right? Okay, but bisect means cut it into.
2.
But by definition, bisect means to cut it into 2 equal parts. 2 equal parts. Okay, this is where you take your sandwich. Okay, so any of you got siblings? Yes, if you have siblings and your parents actually give you some food or something, or like here's a cookie, you split the cookie, right? You have to split it with your sibling. Yeah, okay, so that's normally what happens. Some fight ensues, and then, yeah. So neither of you end up with the cookie. Now, I'm going to show you guys how to do this. So there is a formula, and that's to find the midpoint. The midpoint formula. I don't know if you guys remember it. It's basically, so the midpoint would be this plus this divided by 2. So in my coordinate, so this is for midpoint, formula is going to be y2 plus y1 over 2. Oh, wait, x. Sorry. I screwed up. Coordinate. I put y first. comma. There you go. So for those people that forgot it because, it's been a long time since you did any geometry. Did you guys do this stuff last year?
Yeah, we, in pre-calc I did.
The midpoint formula and stuff?
Yeah,
Do you already remember it?
somewhat, yeah.
Somewhat, kind of? Okay, good.
I remember the half thing.
Okay, yeah. So, that's the formula. So, I'm going to take this, so that's going to give me 17 plus 3 over, crap, I did it again. Now, and the other one's going to be 6 plus 2 over 2. So that's going to give me 8 divided by 2 is 4, and that is 20 divided by 2 is 10. Now we can put everything together. I want the equation of a line of the perpendicular bisector. Now, look to see what we have now. This is the
Slope.
slope, right? And we found the
Midpoint.
midpoint. Okay, so that means that I now know where the middle of my line is, right? The exact middle. That's the midpoint, right? So is that point on both lines? It's on the line here, right? So if I'm looking at a horrible example of a graph, so 2, 3 is going to be right here, and 6, 17 is going to be over here, right? So right there, what I'm doing is, so the midpoint of this is right here, it's in the middle, and that's going to be 4, 10. And I know that it's going in this direction at a 90-degree angle. Like that. That's what we're making here. So that purple dot, it's in both lines, isn't it?
Yeah.
Okay, so now look carefully what we have. We have the slope and we have the,
Point.
so we could plug it into
Slope, point.
point slope.
Point. Okay.
Yes?
Yeah.
Good. Do it. Yes, no, maybe?
You got that.
Yep. Okay, good. So, application linear functions, okay, represent quantities in the real world, not all unusual for the relationship between them to be linear. We have seen defining characteristic for a linear function is equal to increments of the independent variable must result in equal increments of the dependent variable. What that means is, when you look at it like this, whatever equal parts here, it's also equal parts here. So whatever going up, so it's not going to be like, you're going to have a big chunk in between these where these are not all equal parts. So we're going to get into some of this later on, like in Unit 3, where these are going to be unequal parts. But all the linear stuff that we're doing here is going to be equal parts. Okay, relationship between temperature on the Celsius and Fahrenheit scale is linear. Find the linear equation for converting Celsius temperature to Fahrenheit and Fahrenheit temperatures to Celsius. So convert this to Fahrenheit. Now, first thing I'm going to do, This is in. So my first point in Celsius. Where does water freeze in Celsius? Okay. 0 degrees Celsius, right? And where does water freeze in Fahrenheit? 32 degrees. 32 degrees Fahrenheit water freezes. So we're going to do some coordinates for this one. So let's say freeze and boil. This is going to be my, let's go Celsius, comma, Fahrenheit. Celsius, comma, Fahrenheit. So freeze and boil. And if you've ever taken your chemistry or physics, water boiling is dependent on what? No, there's one other thing. Because water boils at different temperatures depending on the what? The amount? No. Huh? Don't feel bad about this, seriously, because everyone has different education, so that's why, have you taken chemistry?
Yeah, I love it, but it seems like, man, I don't even know.
Really?
No, we just straight up boil it and just build it. Well, it's already pre-boiled for us. And then
Pre-boiled.
pre-boiled water.
All right, you. What do you think? You gotta have an opinion on that. Just likes the chemistry.
I thought it's just take heat and then metal and then don't.
Okay.
boil it.
So, right here, if you were to boil water here, it would be 212 degrees Fahrenheit. Okay. If you were to boil water in Denver, it is 195 degrees. 195 degrees. Why is it less in Denver? Are you kidding? It's hotter here.
I've never been to Denver.
Okay, so what is where's Denver at?
I don't know.
It's in Colorado, okay? It's in Colorado. No worries. Okay, it's in Colorado. Okay? Now there is a slogan. Anyone follow sports? No?
No.
Good. Okay, it's a waste of time. It really is. Okay, do something better. Now, it's referred to as a mile-high city because it has an elevation of over 5,000 feet. So, the water boiling point at sea level is normally what you'll see it referred to. At sea level, it would be 212 degrees Fahrenheit. Okay? Higher you go up in elevation, the lower it boils. For people that do you guys know what, like skydiving, right?
Yeah.
Skydiving, that's really high up there, right? Now, there is the thing called halo jump, which is, it is so high up you need oxygen. Okay, so you need an oxygen, it's called a halo jump. Now, with that, you have to have a pressurized suit. You guys remember 5 years ago, some guy jumped out of a balloon from the stratosphere?
Yeah, something like
Okay, so something happened, he had a rip in his glove, and something happened there. Do you guys remember?
that.
He was so high up that his blood would boil. Because water boils at room temperature if you're high enough up. It goes with the pressure. See, now you guys just know something. You guys got a wrinkle in your brain right now, right? I know, right? Now you go on skydive, but, okay, you don't want to do a halo, okay, because you have to have the oxygen and you have to have pressure suit because if you get a cut, your blood will boil. Yeah, they have that same problem for people in space. That's why they have to wear a full suit. They can't just have their extremities out in space. Right? Does that make sense or no?
Yeah.
Nonsense? Okay. All right. A lot of nonsense, dude. Anyway, so freeze, it is 0 degrees Celsius and it is 32 degrees Fahrenheit. Right here, boil is going to be 100 degrees Celsius to 12 degrees Fahrenheit. I have 2 points here now, right? I have 2 points. So what I'm going to do is I'm going to use those 2 points to try and make an equation for converting between Celsius and Fahrenheit. Those are the 2 things that I know. And so I'm going to use that because I now have 2 points. Let's do that. So now it's going to be 212 minus 32 over 100 minus 0, which, what's that going to be? 32, so 212 minus 32, what is that, like 180? So 180 over 100, which is going to give me reducing 9 over 5? Yeah, 9 over 5. So 9/5. So my slope is 9/5, right? Okay, so now let's find a way to put this together. I now have the slope in between this, right? Because these are standard unit of measurement, I can now make an equation out of this. So it's 9/5. Now I want to use which one do I want to use? Do I use the freeze point or the boil point? Freeze because it has 0. So let's go ahead and plug that in. So it's going to be y minus 32 equals 9 over 5 quantity x minus 0. It's actually not y and x. It is Fahrenheit and Celsius, right? Yeah. This is the equation, right? But we're not using x's and y's. We're using Celsius and Fahrenheit, right?
Yeah.
So I plugged it in using point slope, but now I'm going to turn it into the variables that I'm using because in this class, we actually don't always use x and y. We have something like this. So this technically is f minus 32 equals 9 over 5 quantity c minus 0. Okay, now I'm going to simplify it out a little bit. I'm going to simplify it out. So I'm going to turn it into slope intercept. Slope intercept, I'm going to go and distribute this. So that's going to be 9 over 5c. And if I distribute it here, what's going to happen? Anything times 0 is 0, right? That's why 0 is a nice number. And then add 32 to both sides. So now I'm in an equation to evaluate any. So this is now the standard equation for, converting in between Celsius and Fahrenheit. Depends on what I have. All right? That was all part A to this. Now convert 20 degrees Celsius to Fahrenheit. Okay, let's use what we just did. So 20 degrees Celsius. So I'm gonna plug that in for what variable? For the C, right?
Yeah.
Okay, I'm gonna plug it into the C. And if I was trying to convert The other, and I'm given Fahrenheit, I would replace that for my Fahrenheit, right? So this is going to be F equals 9 over 5 times 20 plus 32. F is equal to, so some mental math, because the bottom number is always the division, the top number is always a multiplication. So if I'm multiplying by a fraction, I can go 20 divided by 5 is 4, times 9 is 36, plus 32, 68 degrees. Am I boring you guys to death? Okay, so I don't know if you guys actually have learned this, so that's why I'm explaining. So, mental math. If you're multiplying a number by a fraction, any number by a fraction, the top number is a multiplication, the bottom number is a division. So to mental math this, I can do my division first to make my math easier.
Wait, hold on.
You ready? So, the bottom is division, so let's do 20 divided by 5, 4, and then times the top number. 4 times 9 is 36. So you can mental math this a lot quicker by doing it like that. A lot of people just learn, okay, let's multiply the top, then divide by the bottom. Where in order of operation, and it's whichever comes first. Multiplication or division, whichever comes first. But if you're multiplying by a fraction, they're at the same time. So you could choose to do the division before the multiplication to make your life easier in mental math. Does that make sense?
It kind of gets hard because when you think of 20 and then you divide by 5, but then due to the division side, I think it's 9 divided by 4 instead.
Oh, okay. All right, so let's try the next one then. So that one's Fahrenheit is 68. The next one was 95 degrees Fahrenheit to Celsius. So I'm going to go 95, yeah, equals 9 over 5 C plus 32. All right, going through this one, I'm going to start by subtracting the 32 because I have to isolate my C. So subtract 32 to both sides. That's going to give me 63 equals 9 over 5C. Now to get C by itself, I'm going to divide by 9 over 5. But dividing by a fraction, yep, I can multiply by the reciprocal. And so my reciprocal is going to be 5 over 9. Now, mental math again. Mental math again. So since I had that fraction, we can do division first. So 63 divided by 9
7.
times the top number times 5?
35.
35. So 35 degrees Celsius. So mental math, a neat trick.
Yes.
So all right. Is that what our last slide? Oh, we still got a bunch more too. Yeah, we got some more. All right, so this is what I'm going to do for you guys. So we're going to pause right here, and then we're going to take a break. Yeah. All right. Okay, let's continue with what we're going on here, right? For all those people that actually did the discussion topic like I asked Denny. Anyway, all right, so from here, okay, solving two linear equations simultaneously, so that means that we are going to actually, where these two lines are going to intersect. Yes. Cross. Okay, where they intercept, you'll actually have a cross, x and y. There are many ways to do this. Retrieve. Okay. So, find the unique pair, x and y, that satisfy both of these equations simultaneously. Now, we could use substitution, we could use elimination, we could use matrix, we could just not use our phone. That would work better. So, from here, I like using elimination. Okay, eliminate makes us have the magic number. What's the magic number? 0. 0 is a magic number. Okay? It gets rid of stuff. And so when stuff goes away, everything gets easier. So I'm going to use a magic number. So I'm going to either cancel out the y's or the x. So what I'm going to do here is I'm going to do the y's because I already have my positive and negative in place. So I'm going to multiply the top one by 3 and the bottom one by 5. So when I do this, I'm going to distribute, and that's going to give me 9x minus 15y equals 39 times 3, which is 117, I think.
117. You said 121.17. I wasn't sure.
I rounded up, then rounded back down. So I took this to 40. So 40 times 3 is 120, and then subtract what I just added back on. Yeah, that's my mental math. I do weird stuff. Next one. So I'm going to distribute the next one, which is going to give me 10x plus 15y equals 35. And what am I doing with those? Add them. The better word for that is combine. Because if you think about it, adding or subtracting it implies an operation. But combining implies that whatever sign is in front of that number goes with my operation. So if I have a negative 15 and I have a positive 15 and I combine those together, hopefully that makes a little bit more sense. Combine those together, those will give me 0. And I have a positive 9x and a positive 10x. If I combine those together, I should get, say, 19x. Very good. So combine these together, I get 0y. So if I have 0y, doesn't that just go away? Yes. 0 is a magic number, right? 0y. 0 times y is 0, so that variable is now gone. Bring down my equal sign. So I get 117 and 35 is going to be, what's that going to be, 40, 52? Maybe? Okay. And then to get x by itself, I'm going to divide by 19. And let me see, x is, what's that going to be? 8?
Is that 17?
19, sorry, my thing did not come out. I think that's 8. I kind of suck at math, so I need you guys to double check me on this. Like, quite often I just guess at stuff and hopefully or I'll intentionally give you a wrong answer to make sure you're paying attention. Yeah, I do it intentionally. Yes, I give you wrong things intentionally. Yeah, it is 8. All right, so now I know what my x is, okay? So, just like everything in my life, I always try and get everyone to find my x.
No.
But a ting.
No. actually cringe.
Come on, anyway. And since you're always looking for my x, you also need to know why you're looking for my x.
She got rid of the X.
Ting.
Shut up.
Anyway. All right, so I'm going to put the x into one of these equations. Does it matter which one?
No.
No, it doesn't. So just go with the easier. I like the bottom one because I don't want to mess with that 39. So 2 times 8 plus 3y equals 7. 16 plus 3y equals 7. Subtract 16 to both sides. 3y is negativo 9. Divide by 3. Y is negativo 3. So my ordered pair is ocho y negativo tres. Das gut. Yes. Okay, good. All right, hopefully it's a good refresher at least of what, trying to find these things. We're going to do a lot of algebra this first unit. This first unit, a lot of algebra. Okay, unit 1. Right now we're still in unit 0. But unit 1, whole bunch of algebra. It's actually everywhere. Okay, blah, blah, blah. Look, see, they did using this, which is, yeah. And I left it on your notes because I hate doing this. Okay, I hate doing problems like this, especially if it is.
Oh, the substitution.
Yeah, I hate that. You only substitute if you have to, or it's like a simple substitution. I hate doing this. That's cringe. Seriously, I love math and I hate doing that. That's bad. Blah, blah, blah. Okay, you can plug them into the calculator also, and you find the intercept point. Bam. Now, did I have you guys download the calculator?
The num thing.
Numworks.
Yeah.
I did?
Well, I did.
You did.
Because
Did
you
you?
said to download it.
No. Did you?
No.
I was here.
It was on the first day you said download numbers, or is it second day?
Now, I have something even better for you people.
We're good, Where is it? Matrix manipulation. Oh no, it's the matrix thing.
Now, these, what's the answer to everything?
Yes.
42. 3, 45, 46, 47, 48.
That was a plastic wrap, dude.
Now, why do you think it's wrapped in plastic?
There we go.
Because it's brand new.
What happened to your old one?
I have to change out all the batteries. You, this class, I wrote a grant for you guys to actually borrow these calculators. These calculators are now going to be assigned to you for this semester. For this semester, right? Okay, you are responsible for these calculators. You are checking out these calculators from me. So, these calculators are super amazing, awesome. I expect you to bring them to class with you all the time. Okay? They are brand new. This is why you could have nice things. So your family ever buy a new couch?
Don't sleep on the couch.
No.
We don't sleep on the couch.
I know, but you ever buy a new couch?
I never went shopping.
Oh, okay. So it comes in plastic. And sometimes some people, like going over to my grandma's house, she actually had a plastic cover on the couch because she didn't want anyone to, see, yeah, she does. Oh, the
We have-
plastic cover on the couch.
We have it on our bed though, we like sleeping on the plastic.
Ugh, cringy, that's so sweaty. Anyway, but still, it's brand new, it comes like that. So, kinda like when you get a brand new phone.
Why is this part here?
Okay, brand new phone, what do you get when a brand new phone? You
Well,
peel the
yeah,
plastic off.
it's the peel.
And so it's the first time someone's gonna use it, so you get the opportunity to. Go ahead.
Imagine I
Go
never.
ahead, go ahead. Or you're just gonna try and leave the plastic on all year.
I wonder how Patrick,
You could take the plastic off.
I wonder how Patrick would feel if I just leave the plastic on.
I get it all.
So super cringy.
Plastic.
Yep. So these are going to be assigned to you for this year, so please do not lose them.
How much?
Okay, they're $150.
Oh my gosh, more expensive.
They're $150. Yes.
I mean, I can bring like our other one in case.
Yeah, if you want to. They're rechargeable, and I will give you the recharging cable here in a little bit at the end of class. So you guys can plug it in using any USB.
You don't have no covers?
Huh? I will get those too. Yeah, that's what the rest.
Because my hand goes down like.
All right, so that being said, okay, I'm hoping you guys appreciate that we have nice things.
Thank you, Patrick.
Okay, so I'm gonna leave off there. You guys go ahead, and your assignment for tonight is the quick review. The quick review, which is there's 2, 3, 4, 5, 6, 7, 8, 9, 10 problems.
Okay.
There's 10 problems for you. That's gonna be your homework.